Alright, React hooks in action. Hooks have taken the React community by storm. Many open source contributors have started implementing awesome stuff with hooks as soon as the alpha version of hooks was released in the last year. This created lots of hype around the hooks topic. It was released this year in March, and since March, many people already have adopted it, with stories being around from people migrating their Redux applications to hooks because it's cleaner, lighter, and I feel it can change the way on how you program your React applications. First, an intro about me. My name is Martin. I'm working as a lead full stack engineer at AutoScout. I'm creating data-driven products for commercial car sellers. My working stack is Scala on the back end, TypeScript and React in the front end. So if you want to join me with that, we can have a chat afterwards. For my personal interests, I love my family, functional programming, photography, bouldering, and board games. Alright, I've just put up here 2 links. One is to my website and blog, which is rather empty right now, but I will fill it with content. And the second one is my Twitter handle. So if you haven't already, follow me on Twitter at m4nl5r. So let's start with the question, why hooks? One question here to the audience. Who has heard of function components? Awesome, that's quite a lot of people. Then a bit more controversial question, who prefers using function components over class components? Also, quite some people. Awesome, guys. Very cool. So, in my point of view, function components are actually easier to understand than class components, because function components is a function which returns some UI. With classes, you have to deal with stuff like this binding in event handlers. Nobody fully has understood how classes work under the hood with the inheritance system of JavaScript. Also, what I've read from the React people is that function components are easier to optimize than class components. So hopefully you'll get better performance out of it if you're using function components. So pre-hooks, function components were missing some features, which we'll look at now. LIFECYCLE, function components had no way of doing things at render or doing it at every render. Something like component did mount or component did update wasn't just possible. It's possible to emulate this behavior with hooks, but actually the hooks behavior is better, which we've seen a bit later. Also, your function components cannot have state. Like this .state isn't available in function components. You cannot use no. This is actually good because it prevents you from blowing up the function components. But on the other hand, it makes it very hard to build full applications and only built by function components, because usually most applications have some state. I mean, there's solutions for that. You can use Redux or some other state management libraries, but I feel with hooks it's way easier and it has a very good developer experience, in my opinion. Next question here, who likes complex component hierarchies in their React applications? Yeah. Yes, Adam, awesome. I do not, and as I've seen, all of you also do not. So this is about reusing stateful logic. I've put up here an example for doing some internationalization. There's some abstraction over some APIs. So I will show you how this will affect the component hierarchy. So there's one pattern which people might know. This is render props. So what's happening here is we have a translation component which expects a function returning another component as child, and it injects the translate function via this function, and you can then use the translate function to translate your translation piece. That was a lot of translations. You can also achieve the same behavior with higher order components. So a higher order component is a component wrapping another component, basically. So here you see the pattern of props injection by the higher order component. So you have your component which has the translate function as a prop. You can then use it in your component, and you have some higher order function from a library which injects the translate function, wrapping your component. This also adds a layer to the component hierarchy. So if you open up DevTools, you see that you have the higher order component and then your component. So this also adds complexity. So a quick spoiler here, this is the solution with hooks. So you have a use translation hook. This gives you the translate function. You can just use it. It's very concise, short, and you understand on the first side basically what's happening there. And this is what's selling hooks for me, because it's very easy to use. It's very easy to understand what's happening. So very awesome. Let's talk about your first hook. So we managed, or I mentioned earlier that state isn't available for hooks. So we have here a class component, which is the classical example of a counter with a button to increase the counter. So if you look at that, you have a constructor initializing the state, then you have the labeling, and then you have the state setting function in here. This is how it looks with hooks. I've even added a bit more boilerplate here with the import. Basically what happens here is here we use state hook, which takes an initial value, which is here is 0, and it gives you back an array of the current value and a setter function. And once the setter function is called with a new value, there is a new render of the component, and the new value of the state variable is being bound. So here to the count. So what happens if you click, then the count is increased by 1, then there's a render, new count of 1 is in here, in this array, and also look here, it's constant. It will not ever change within one render. A quick demo here. I hope everything goes well and the bird does not explode. So I have here code sandbox, so that's the component I've just shown you. You can click here, and it's increasing the counter. Yay, that's our first hook. Another cool feature we're having here is that you can actually use callbacks in the set count. So this is a callback which has the current state and returns the transform state. So here you could actually write it like that for the increment. There are two rules of the hook club. First rule is don't talk. Just kidding. Only use the hook's top level. Don't use them in if, for, whatever stuff. It's not working and your application will explode in some way, or you will see weird behavior. And also, it's only possible to use it in React functions. So a hook function cannot be executed on their own without being embedded in a React function component. You cannot use it in class components as well. So this is like very important. Hooks is for function components only. So the people of Facebook don't trust their developers, so they have created some ES and TS plugins for React hooks, which check that you don't violate these rules. So please feel free to use them. And while I'm mentioning the TS lint here, TypeScript is fully supported. I'm using it and it works pretty well. So let's move to the second hook. It's a bit cooler than USEEFFECT. USEEFFECT. You can use it to run side effects outside of React. It's executed after every render, unless specified otherwise, and it's triggered after rendering and before painting, but it's not blocking. So the painting does not wait for the effect to finish. And this is a major difference to the behavior of the component lifecycle, because the component lifecycle does wait for the component lifecycle function to finish before it starts painting. Also, something which might be a bit interesting is that the props and the state are bound to the wrapped function in the effect. I will show you later what this means. So here we have the same counter function component, but we have now an effect function which sets the document title to the amount of times you've clicked this button. So this is the most simple example. What you see here, USEEFFECT takes a function, and the values you use, for example, the count will always stay the same for one execution of the effect. This means if you do some asynchronous stuff in there, where you've been used to have the latest value with this point state, this is a major difference here, because on every render and execution of the effects, the values stay constant. So I've prepared a mental model for rendering, which I've just explained a bit. So first of all, the counter is bound to 0. Then the component creates the render result and dispatches the effect to React. React renders to the DOM, the browser paints, and meanwhile React is running the effects. So actually the browser painting and the React running effects can happen concurrently and it's non-blocking. So this might also affect your user experience because the UI feels a bit smoother in the end. Then we click the button, then the counter is...
Won't it have interactions, like if you, in your side effect, if you change the DOM, and if React changes the DOM at the same time, won't that have like weird...
I think so, and you probably won't do that.
Alright.
Or you should not interact with the DOM created by React. So I think you can interact with the DOM outside of your React application. But once you start messing with the parts of your React application, which is controlled by React, I think you see weird things. It's the same as if you would use jQuery or something like that to mess with the DOM. Alright, then the component creates the render result, dispatches the effect again. And on the second execution, what's new is that React is cleaning also old effects up. If you tell React to do so, so we'll see that on the later slides. So one example where the cleanup is needed. So let's say we have a component which, as an effect, connects to WebSocket with a customer ID, and we've seen that this effect hook is executed on every render, basically. So here there are some problems. If you do it multiple times, you have multiple WebSocket connections, which you probably don't want to have because it's leaking resources. That's why the effects API can clean up the effects as well. So if you return a function, this function is being executed in the cleanup phase of the effect. Now we have plugged our resource leak. Now we have another problem. So let's say this snippet of code is embedded in some application with multiple properties or state variables, whatever, and once some other state variable changes, there's also a render invoked. That means here that you disconnect and reconnect even if the customer ID stays the same, and you probably do not want this behavior. So they have a feature built in that you can specify the dependencies of the effect in the form of an array, and if the values in this array do not change, the effect isn't executed a second time, and it's also not cleaned up. Warning here, this is a major source of bugs. Please always make sure to put really every dependencies in, and also try to minimize the dependencies. I will show you a bit later how this can be achieved. There's also the use case that you will probably only want to execute a hook once. For example, if you run some page view tracking or stuff like that, you don't want this to be executed on every render. For that use case, you can just specify an empty array of the dependencies, and then this effect is only executed in the initial render. So I told you about minimizing the dependencies. So let's see what we have here. We have an effect which creates an interval which increments the counter every second. And for the increment, we set the value directly. So this effect is actually depending on the count, because the count variable is used inside the effect. Is it clear to everyone? Good. I see some nods. But it's possible to remove the dependency to the count variable. That means that we don't have to set and clear the interval at every increase of the counter, and we can just let it running. So the solution is, as I've shown you earlier, this setCount function also can do some callbacks. And with the callback, which just increases the value, we got rid of the dependency on the count. Everything cool. So I have another question prepared. Can the component lifecycle methods be modeled in a similar way to class components with USEEFFECT? What's your opinion here? Yes or no?
Depends. Well, not all of them, but...
Yes. So there are some major things. So there are some lifecycle methods which are not yet supported by hooks, and for the component did mount and component did update, they have a blocking behavior, and USEEFFECT is non-blocking. Luckily, they also have a use layout effect hook, which can emulate rather similar behavior. So yes, it's possible, but USEEFFECT is actually behaving a bit different here. Custom hooks. So the good thing about React hooks is that you can build your own hooks composed of other hooks or just some functionality. And I want to show you that by an example. So custom hooks by example. So we have a data fetching from a JSON-based API. We want load handling because we want to show a spinner or some fancy effects to the users while the loading is happening, and we want to have error handling. So if we want to show some error message or whatever. So first of all, if we think about the stuff we're having here, we have 3 states basically. We have error, loading, and data. Also, what's a bit different to the class component here is that you don't have to put everything in a big state object, but you can have like 3 states here, or 3 state hooks, variables, whatever you want to call it. Also, well, we know that we want to return the error, loading, and data, and we want to use some effects probably to fetch it on the loading of some component. Let's progress a bit here. So probably the data fetching is an asynchronous function, so we have an async function here. When it starts, we want to set loading to true and we want to set error to null. And after the execution, we're going to set loading to false. And afterwards, we want to just call our function. Then when the effect is executed, our function is being executed and all this stuff is happening. So I've preemptively put here URL as a dependency because probably if the URL is changing, we want to have some other behavior. So in the end, we use some HTTP client, for example Axios. We could have done the same thing with the fetch API. If we wait for the response, set the data, or set the error. Yay, everything awesome. I've prepared a quick demo for that as well. Loading the code sandbox, so you see here loading, and afterwards we get some numbers. So I've been using the Hacker News API to fetch the maximum ID they have currently. What I did here is I've added some delay that you can see the behavior with the loading, and afterwards you see the data. If you look closely here, you also see some use API test.js, so it's also possible to write a test for your hooks. Click here. Those are being executed. One has passed already, two has passed. Yeah, great, awesome. I will show you the test code on the next slide because it's a bit better readable than the code sandbox, I guess. Testing.
Is there a reason that you'll fetch down to a function declaration next to inside USEEFFECT?
Yeah, that's actually a good question. You could plug it in directly as well, I guess, but you have to make sure that your function really gets executed. So in the end, the common pattern is to have an anonymous function in the USEEFFECT, and then having your function in there, and then calling the function. You could also do that with an immediately invoked function expression. But I think, I'm 100% sure, so if you put the fetch top level, it will not work because it's returning a promise and the function should return nothing. Yeah, I think Thomas is right that we also will get a warning that we should not do it in the console. Adam?
What if you wanted to have like a refresh button on the UI, right? So every time you press that button, then it makes the network call again. How would you wire that in with the hook that you wrote here? Would you have to provide a callback from the hook then that you would wire up to the button, and then that would kind of work in place of having, a traditional callback, which would immediately go fetch? Or
so there are some other ways or other hooks. So you could use callback for that. That's also in the presentation a bit later. I can show you that. Also, what you could do is, if you have a bit more complex behavior, then you could use reducer for triggering that, actually.
use reducer to trigger a network call? Would that be for updating state?
So you cannot use, execute the effect directly, but you could basically set the same state from another point of view, I guess. But I haven't fully thought this through. This is a bit too ad hoc right now. All right, testing the custom hooks. So there is actually one problem which I've mentioned earlier, that you cannot execute the functions with the hooks inside without having a function component. And there are some hacks around, or you can just use some library. For example, the React testing library has a React hooks flavor. It provides you with a render hook function. Then you have to mock your HTTP call. We said that we return some fake data. Then we actually render the hook, and here we get two things out. First, we get the result of the first render, and we get wait for next update. Now what's that? Because we're having here asynchronous code inside of the hook, the React testing library only executes the first tick basically. Then you're in the loading state, which you see here in this in the expectation. Then we wait for the next update. The series awaits there. Afterwards, we should not be loading anymore, and we should have the data. And I think you can test pretty much everything following the same pattern. And I feel like it's a very clean way of doing the tests basically here. Alright, that was it for the custom hooks. There are some other hooks as well in the React API, and this is also my last section for the talk. Use context. Sometimes it's useful to access the context API. Use context gives you a value out of some context, and once the context provider updates the context, a new value is being put in, and a render of your function component is triggered. That's all. It's all about it. Use ref. Ref is a hook which gives you a box which can contain mutable variables. Why is that useful? The box memory address will stay the same. So you will always have the same box, but the contents can be mutated, and it's the only native way of having mutable values between renders. I think it's sometimes useful, but there is not too much around it. You can also, so here is one example where it's useful, because here's some async stuff happens. So first of all, it's rendered, then you have the ref, which then fills the, puts the value of the ref from the input into the use ref, and then you can use it. If you would have just bound the value in the first execution, then the input would not have rendered, and you would not have access to the button, basically. Does that make sense somehow? Alright, let's move to the next one. There's use callback. Use callback can be used to minimize some callback until the dependency changes. This is very useful to pass around callbacks, which stay the same and will not trigger re-renders. So this is basically can be used for performance optimization. You can also plug the use callback in as a callback ref. So here the use case is that we want to get the height of an element, but on the first execution, on the first render, we don't know the height, so we use a callback, which takes a node, and if the node is not null, gets the height of the node and writes it into the state. And here you see the zero dependencies. That means that this callback will never change. And as you see here, it has zero dependencies because the node is part of the function signature, and it's not some values used from outside of the callback. And then you can plug it in the ref. This is then executed similar to a ref function, and the state is updated, and then you see the height. Then there's a fancy one, use reducer. So this gives you back a state and a dispatch function. Note that the dispatch function is static. So this dispatch function will never change between renders. This is guaranteed to be static, and if you use it within USEEFFECT, for example, you do not have to specify it as a dependency. It will never ever change. So use reducer is then in the end quite similar to what most people are maybe used from Redux. So you have a reducer function, an initial argument, and an init function. When should it be used? I guess it should be used when use state is not enough anymore, basically. So when you have some a bit more complex business logic or complex interactions, it might make sense to use reducer. And it can also be used when you need the static property of the dispatch function. So one example here to show that it's really similar to the Redux thing. So you have an initial state, you have a reducer function which listens to some action types that have a state, and it returns the next state. Then you can just use it. You have here two buttons who can dispatch the actions, increment and decrement, and that's all about it. I guess you can create your own a bit more complex examples. For that, it's maybe not too useful yet, but I think once your application scales, it really makes sense to have that. Last one, use memo. This is used to memorize an expensive computation. Note that it will be, get executed on the first render. So you probably do not want to do something too expensive, because too expensive things you probably want to do asynchronously to not block anything. And the value is recomputed when the dependencies change. Yeah, and then it's also re-triggering render. Alright, final slide for me. Hooks in the wild libraries. 2 weeks ago, React Redux have released their hook-based API due to popular demand. This gives you hooks which give you basically direct access to the store and to the dispatch functions. And then you have React Apollo hooks, for example, for GraphQL interactions. You have React I18 Next for translations, which I'm using in productions. And there's a very cool website, Hook Search, it's built by Nick Graf from Austria, where you can search for libraries providing you with hooks. So that's closing out my talk, hopefully. I want to say thanks to Adam and Thomas for organizing the meetup. I want to also thank all the people from Scout who were helping me here to run this meetup, Diana, Enrico, and Simon. Thanks also to my company here, Autoscout24. I honestly believe it's a very good place to work for. We're hiring, by the way. And at last, thanks to everyone for being here, and making it an awesome event. Thank you.
Any questions?
Yes.
Quick one is, will you share the slides?
Yes, I will. So the presentation I did here is already on GitHub pages, so I will just drop the link on my Twitter. Just follow me on Twitter, then you can get the link.
But another question is that in your application which you're working on, I guess you're also already using hooks.
Yes.
Do you also have like store which you're using to handle the state of the application, like either Redux or
So right now the thing which I'm building hasn't become so complex that I felt the need to use Redux. So I'm using this user API hook to fetch some data. I have some states and I use some other effects to do certain things. But right now I'm not doing very fancy things with hooks. So I've also just started with it. I'm using it in a greenfield project, so I did not do any migrations, but we have here someone with a migration story, so feel free to ask him about how to migrate from Redux to hooks. I think you can provide some value there, some stories. Alex, you had another question?
Yeah, could you go back to the API example, the user API, where you first showed the hook implementation?
Or is that? There was that one, right? Yes.
Yeah, so my question is about the possible performance problems. So when, as far as I understand, user API is executed on every render, right?
It's only executed once the URL changes. So we have that as a dependency here.
Yeah, the effect of the user API itself, right?
No, it's not.
User API is executed upon every render of the software. So the function
It's not level function.
Yes, it is.
Yeah, and so.
But it's not doing anything, basically.
Yeah, not doing anything, but it's calling 3 times use state and 1 time use effect. So I was wondering if you have like just a hook which calls 20 hooks internally, if at some point you get some performance problems.
So, frankly, I did not experience any performance problems yet, because I'm also on the start of my journey. I can imagine that you want to optimize a bit when your applications become more complex and big. So, but for now, so I'm doing some data fetching, then you can change what data will be shown and stuff like that. So far this was without any performance issues or performance penalties. But maybe you'll find here someone who is more experienced with performance issues with hooks. Is anyone here?
So I found a blog post by someone who said hooks are much slower than class components, and actually then Abimov, the inventor of hooks, replied back, you should enable production mode, and then actually hooks are faster normally than class components. And that's just a more general perspective, not in the specific examples, but hooks aren't slow, that's the question.
And one other question, at the very beginning of the slides, you showed this use translation or something.
Yes.
Could you go back there?
That was that one, I guess. Yes.
I guess somewhere it's not stateful, not actually, right?
Yeah, so I took that from the React i18 Next library, which is a wrapper around the i18 Next and it has some advanced features, fetching the languages, switching the languages, and they're using the context API under the hood. So that's why you need a hook here, but you're totally right that you could do internationalization in a much easier way. That was like really just a random example.
I'm not saying that you don't need it, I just don't see why I would need it.
So here it's needed basically for the abstraction over the context API.
Okay, thanks.
I have a question, but well, my React experience is very common, so it might be misplaced. I'm wondering whether the USEEFFECT is basically a queue or whatever it is a stack in the background, and it doesn't even matter because execution order might be important. If you modify the same resources from different rows, it might reduce some artifacts, at least from the way of using the
Good question. I think this is like targeted towards when you execute the same effect multiple times. For example, if you have some very slow computation and you do some state changes meanwhile, and the second computation is triggered. So I'm not 100% sure. The behavior I've experienced is that every execution of the USEEFFECT will finish, basically, and they're finished in order somehow.
probably first out the queue.
But I'm also not aware that I've seen that in the React documentation, so probably you'd have to look into the source code to find out what they're doing there. All right, anything else? Still another question. Great. Yes.
So you now have experience with both the hooks and also the old React components, and this is like slightly pushing you, but could you give an argument for why not to use hooks? Or like what would be the
No. I would just say use hooks. So even with hooks, I try to minimize the class components usage because function components feel more natural to me because I'm very much into functional programming. So if you think about your UI components and about functions which return some UI, I think that's a very easy mental model. But then having a class somewhere, I don't know, that's just not feeling right for me. So also in my, I would say backend programming, I'm not using many classes. I try to use abstract data types, but no real classes with state in them. Sally?
Yeah, so one downside that I actually noticed while you showing examples is that you have to know them really well in order to understand how this code works, because I think it has to do how they implemented them, because even when you explain here's a function with a hook, but when you return a function out of it, then this will act as the deconstructor, or this function will be called when this effect should be removed, let's say. Or if you pass the array, it will be executed only when it's changed. But if it's an empty array, then it will be executed once. Like all these things you have to know. There is no way you can guess just by looking at that code, you know?
Yes.
There are quite so many of those, I would say.
Yes, but for example, if you look at the TypeScript definitions, you'll see that like name. So you see that the array is called dependencies. So I guess it makes it a bit easier. But yeah, I'm here totally with you that it might be a bit confusing at first, and you need to get used to it to know which stuff to use when.
Well, but on the other hand, using that state isn't intuitive either with a class component, right? That's like, it's very, you have to learn a lot to use it properly. So I think it's a balance.
I guess also. Get another question.
No, it's not a comment. In my current project, we were using a lot of higher order components to recompose, and since spring we also introduced hooks and converted a lot of code to hooks, and it makes code much more readable. So we use TypeScript, and typing all these nested higher order components.
That is madness.
It's really mad. You get types which make no sense. Also, as a programmer who came into the project and looking at already existing code, with hooks, the types get much more simple. You can give local names. So when you extend the property lists of this all web components, you have to invent a lot of quite general property names, and this give the hooks you have the names much more local.
Yeah, I've fully agreed here, and it's also aligns with my experience. I'm used to have like that long typings basically with some really advanced TypeScript concepts, and it feels a bit off for the value you gain by it. So I really like that stuff gets easier with hooks. So I'm here with you.
Yeah, also this data fetching API, with this API, we have some similar things. Maybe a little bit more complex. We also have this reload thing built into it. It's really nice. So when you do it with class components, you always use these lifecycle methods to do immediately some data fetching, and the code gets more distributed.
So yeah, one thing as well, in the hooks variation, you have the execution and the cleanup of the effect in one place. While if you're doing it with the lifecycle components, you have it in two places. You have it in the component that mount or component that update, and then the component that unmount thingy. And there I guess it's much easier to also introduce some bugs than if you see it like in one place. I guess that's also a very cool property about hooks. Alright, if there are no more questions, then I suggest we do a quick break and then do the next talk.
Yep. Maybe 10 minutes?
Yeah.
15 minutes?
Is anyone here who wants to go smoke to the street level? Alright, then I'll make sure that you can re-enter.
Thank you.